morning to one and all. First of all, I would like to thank our principal and management for providing an opportunity to conduct this webinar. I welcome you all for today's webinar on Virtual Lab for Experiential Learning. On behalf of all of us, I would like to welcome the research person for today, Dr. K.V. Gangadharan, along with his team, and would like to thank them for accepting our invitation and address us for the same. Before we get into the session, I would like to introduce our speaker. Dr. K.V. Gangadharan is presently a professor in mechanical engineering, head of the Center for System for Design, a transdisciplinary center of excellence, president of Institution Innovation Council at NIT Surathkal. He has earned his UG in mechanical engineering from University of Calicut, Kerala in the year 1989 and PG in manufacturing engineering from NIT Trichy in 1992. Then he gained his PhD from IIT Madras in the year 2001 in mechanical vibration. His area of interest are mechatronics and system design, vibration and its control, smart material and its applications, structural health monitoring and condition monitoring, experiential learning, that is content creation and virtual experimentation. He has produced over 60 significant publications and has earned 7 patents in the area of medical devices and 3 in smart material applications. His other achievements include setup of Center for System Design, a center of excellence with industrial funding, virtual lab project in collaboration with 7 IITs and 5 other institutions, and remote triggered lab. He is also in charge of amateur radio facility in NITK and an active ham amateur radio. With this brief introduction, I would like to hand over the session to Dr. K.V. Gangadharan. Thank you.
Thank you, Preeta. Nice introduction. Welcome all of you to the webinar. I'll just share my screen. The host has to permit me to share the screen.
Thank you, sir.
I request the host to permit me.
Yes, sir. Yes, sir. I've done it.
Yeah, thank you. So hope you are able to see the screen, my PPT screen.
Yes, sir.
On behalf of National Institute of Technology, Karnataka, Surathkal, presently an NIRF 13th rank, 13 rank institute is on the Western Coast. Welcome all of you for this webinar, an interesting journey on this COVID time to see how we can make use of this COVID shutdown or lockdown as an opportunity. So those who have not visited our campus, anyway, you cannot come now. You can have a V-tour, that is virtual tour. It's available on this web, vtour.nitk.ac.in. So we are environmental friendly institute with 1 megawatt of solar power connected to the grid. Let us look at today's topic, virtual lab for experiential learning. I'm now looking at very specifically for Mumbai University, but it is in general for every student, either a learner or a teacher, or even people who are looking for a job or preparing for interview. We'll just subdivide the activity in that way. And we are also specifically looking at this opportunity, COVID-19 lockdown opportunity. We have 3 very specific area of time now, durations. Before COVID, let us call it as BC. And during this COVID period, let's call it as DC, and maybe after COVID as AC. Now, we are looking at learners and teachers, and specifically science and engineering, or job seekers, those who are attending interview or preparing for interview, those who like to upgrade their job or grow in the career, job changing, those who are got into IT, would like to come to core or to management, or in the reverse order, any order. How do we acquire additional skill, additional clarity in concept during this time? Or if you want to put all this aside, how do I learn? How do one learn online? And how do I get an experiential learning online is the question. So when we talk about experiential learning, I'm sure many of you will remember these pictures. So let us assume that somebody is teaching us either swimming or cycling using textbook. I'm sure all of you are going to giggle on this statement. And we don't learn swimming or cycling by textbook. And in fact, that's the same thing we are doing. All engineering faculty members are doing. We make our students to read engineering, expecting them to do engineering. Let us change this approach. Now, we are looking at how do we evolve telling concept to making it experiential. Can I make my learner or the students experience the concept? If so, what is that I need to do within the given constraints in the classroom environment or an online teaching environment? So if you look at Guru, maybe textbook may look like this, but during this period, these have been our gurus. And we have been doing dhyana or meditation like this. But let us not blame this situation. Use this as an opportunity to get maximum out of this lockdown period or when we are forced to do online activity or online learning. Let us take an example. I'm just going to look at one student who is from IT or CS or electronics, want to look at robotics. I'm sure he has sufficient skills and understanding on electronics. Now, but a problem comes, he is looking at a gripper. Now, I'm creating a situation and non-mechanical student trying to look at mechatronics or robotics, and whereas I have created a requirement for a gripper. Now, the gripper, when I look at, this is what I see in normal way. So as a student from circuit branches, quite obviously may not have gone through this. So we are just looking at one gripper for, remember, I'm a non-mechanical student. I'm looking at, basic, electronics or a circuit branch student, have to work on robotics. Now I'll just look at this and I'll ask a mechanical student to bring it down to simplicity. So they say, this is how it can be looked at. So now, as a non-mechanical student, I want to understand whether is there a place where I can get this basics clarity? Can I experience this basic component so that I will understand better in making a robotics? This is situation number one. Now, I'm an aeronautical engineer who have been asked to, or an electronics engineer who have been asked to look at controlling these movements. And I again want to know how these movements are achieved. It's a landing gear. Again, it comes back to a topic called kinematics of machine, which is a mechanical engineering topic. Now, I would like to get this clarity for a non-mechanical student. This is the situation number one. Now, I'm an electrical engineer. I'm sure that vibration, wind-induced vibration is not making our towers to dance like this, but I'm interested to find out what is hanging here. If you look at in this, if you could see the cursor which I'm moving or the red circle which I put, this you might have seen, many of you might have seen in a high tension line or a tower, these kind of things hanging. I want to understand what is it. In fact, it comes from either civil engineering or mechanical engineering, which is called stock bridge damper, which is a sacrificing element in the line, which helps us to reduce or mitigate the vibration which is induced by. If I want to explain it, I should have some way of experiencing what is happening in these situations. So that's what we want to see whether this can it be done online. This experiencing of this activity, can it be done online? Now I'll take another civil engineering application. Type A 101 tuned mass damper or this building. And engineer asked to understand how these vibrations are controlled or how this tuned vibration damper works. He again have to get into basics and have an experiential learning. Now the question is, can I provide all this in an online environment? So my industry is now either I am from a basic branch called mechanical and trying to work on mechanical engineering, or I am from a non-mechanical engineering or any other branch try to understand some in another domain. So these are the two situations for a learner. Quite often we may have to do our own subjects well and understanding well, or another subject which is happen to be using in our required project or required work may have to be understood. So now we are going to specify a dream lab to do all this. So let us see what specification we are going to give for the lab. So I'm going to dream about a lab which provides me all these required input in such a way that the lab should be at my place, especially this time. If I am at home, I need to do the lab at home, and it should be at my pace. I'm so slow learning person, I want to do it at repeated times, or I'm a very fast learner and I would like to finish few experiments in a stretch, or I would like to do it at very early morning. Say I'm an early bird and 4 o'clock I want to do an experiment. Now, I should have the facility for this dream lab to do all these three. A lab should be at my place, at my pace, and my period. So this is first specification we are giving to the lab. Then second, I should be able to take home the lab, or I should be able to carry with me. Let us have a lab with no lock and key and no holidays. And all of us are at home now, and this lock and key and holiday really makes a difference. And after all, this should be suitable for my syllabus. If it is a student or a teacher, they will always look at, is it for Mumbai University syllabus? Or is it help me? Will it help me to get my job? So we are going to put this also as a specification for our dream. After getting a degree, we may have to look for a job, or I may have to change the job afterwards. So changing the job or finding altogether a new job. Or can I shift job from IT to core, or core to IT, or core job to management job, or a new area altogether, different area which I'm looking at. How do I get this kind of understanding on an online mode, and that too with experiential learning provision is what we are dreaming. So, and it should also help me in improving my technical understanding. So we are now putting all the specifications together of the lab which we are dreaming about. So a lab at our place, pace, and period. And the lab where experiment can be repeated. It should be just for our syllabus. And it should help me in my job interview. And I should be able to shine in my present job. Lab that helps me into that lab which helps me. I hope you are able to see my presentation. The lab that helped me in getting my dream job, a lab that helps to grow in the career. These are the specifications we have put now. Okay, let us see what is the dream which is coming true. And all these specifications, if you put together, is the virtual lab. The virtual lab, which is an initiative of Ministry of Human Resource Development under the National Mission on Education through ICT. All the 7 IITs, along with IIT Hyderabad, Amrita University, and Dayal Bagh, and COEP Pune, along with the NITK Surathkal, all the 12 institutions put together created around 100 labs, each having more than 10 experiments. That means you have a bouquet of around 1,000 experiments available in the online mode. And what is this online mode all about? There are 3 different kinds of virtual labs created. One is modeling or simulation based lab, wherein the system's equations are used and that can be simulated and made sure that such things are done. And second is measurement based lab. And where, take the example of an case of an UTM, universal testing machine. I want to test different materials, how these materials ultimate strength differs. So we do all that testing and get the data. Once the data is ready, the student can come and do the experiment, assuming that he or she is getting the same kind of results, and he can analyze. Or the last one, which is very close to reality but not that scalable, is a remote triggered lab, wherein the remote triggered lab, an actual experimental setup is kept in a laboratory and connected to internet And a person from a remote location should be able to control this remote triggered lab. We will see all these different kinds of small demo in this webinar. And the approach is very simple, either a physical lab or which is remotely controlled lab, or a simulation is kept on a server, and through internet the client machines are connected and users should be able to make use of it. And in our approach, all the labs are making use of the client machine. That means when you connect to the server, you get all the required things, and your machine, whichever be the machine which you are using, will be the place where the real virtual lab activity happens. So at NITK, we have done it at the Center for System Design, these activities, because which is a transdisciplinary research center where we put students or people together to make sure that they work on problems, the real life problems, which is cutting across different branches. So we have, our team has done a mapping of your university, Mumbai University syllabus. We will be giving you that PDF in the chat box later. And we'll just see how we can look at few specific examples. I'll stop this share and I'm going to share another screen, which is going to be my let us see how we look at the virtual lab itself. So instead of talking about virtual lab, let us see what is virtual lab and where is it available, how do you access it. So vlab.co.in is a national portal which is maintained by IIT Delhi. The IIT Delhi is the national coordinator for this program. So you can see the virtual lab website. The clearly objectives are mentioned. The broad area of virtual lab is also mentioned there. You can see most of the branches are there. Remember, each of the experiments or labs could be from other branch also, because if you look at electrical, electronics, and computer, signals and systems, control systems, and basic electronics, analog devices, or analog electronics, or digital circuits, etc., are cutting across different branches. These things you should be able to see it in appropriate areas. And these are the participating institutes, as I mentioned. So we'll just see what specifically NITK have developed so that I can demonstrate one or two labs. NITK, Surathkal have developed fluid mechanics, which can be used for both civil, production, and mechanical engineering. Then we have a transportation lab, environmental engineering lab. There are two labs, fluid machinery lab, wherein turbines and other things are demonstrated. We have specific marine structures lab, mining geology lab, and this could be useful even for civil engineering students. Industrial drives, electric drives, substation automation, mechanics of machines lab. Mechanics of machine is something similar to your course ME 405, I believe, kinematics of machine and kinematics of machine. That's what I remember in your syllabus. We have machine dynamics lab and process control, reaction engineering, and unit operations. This is for chemical engineering, strength of materials lab, and dynamics of machines lab. What we'll do is we will just look at one lab specifically. I look at mechanics of machines lab, which is for maybe third or fourth semester mechanical engineering. I will use this to say how we make up this experiential learning. I want to just look at how a piston cylinder arrangement is looking like. I want to know what happens when the radius of the crank increases, how much displacement I get, and what will be the minimum angle and maximum angle for the connecting rod, etc. So if you look at this, I'm just changing the radius, crank radius. I can understand at each position, each theta, where will be my piston positions at every theta I can understand. And I can also change the length and see how for each of these position, how it moves. So it provides me a kinematics of machine wherein just movement of each linkages without considering force, etc. And how it is moved is not the concern, it is only the kinematics. So this is called the displacement diagram or displacement analysis or position analysis. Now, from here, mechanical engineers will go to look at what is the kinetic energy available in each link. So I'm looking at the kinetic energy available in the piston, connecting rod, and the crank. So for that, I need to find out what is the available velocity, and that can be found out using this. So I'll get velocity at each of the positions. So I can change the angle. Those who have taken this course in the class will agree with me. It is too difficult to convince students on this because we drew only one picture. At this angle, this is a velocity diagram. Whereas now students will be able to experience it for every position. And a student who wants to solve a question which has already appeared in an examination can just type in the data either in a scaled version or in actual data and find out whether he is arriving at the actual answer. So that is another way of using virtual lab. Now from here, position, velocity, I'm just moving to acceleration. So here you can see the acceleration also being shown. So position analysis, velocity analysis, then the acceleration analysis. Without getting into the complexity of all this, because we are not worried about the domain, we want to see how virtual lab is useful for experiential learning of any basic concept. So here I should have provisions for changing the parameter. Each parameter can be varied. So student will get a provision for exploring what happens when parameters are changed. So this is one. And the learner should also be able to get the simultaneous values so that he can analyze. So this gives an option for the learner to start with the basic idea of, say, position of a kinematic analysis, then to get into kinetic energy, that is finding out what is the velocity at each link, then get into the dynamic force, which is mass into acceleration, F equal to ma, Newton's second law, where one should be able to analyze it in deeper sense. Now, this can be mapped onto any other subject. Now, I have taken an example from mechanical. Similarly, a person working on RLC circuit should be able to do similar things, or a person who are working at, say, civil engineering on material property or strength of material should be able to do similar experiments, but the concept is going to be same. A system, few parameters, and we should be able to change the parameter. Okay, so from here, we'll see how we can get into the next level. I have now understood the kinematics, but now I am interested to go towards dynamics. So now I am looking at the dynamics of machines lab, wherein the same piston and cylinder, either it is for an IC engine or a compressor. Compressor, we are going to give rotation, whereas an IC engine, we are going to get rotation by the movement of the piston. Okay, so here, this much we have already done. Now I'm going to the next stage, where I would like to know what is the force, the acceleration at the CG of each link. Once I get the acceleration into mass, I'll get the dynamic force. Now I'm going to add the dynamic force here. You can see the dynamic force being added there. Then I'll also look at how, for further analysis, I'm going to do for each of this, each of the link can be separated and find out what are the forces acting on it, etc. And again, the parameter can be changed. So this is a final view, which is called an offset analysis, where one torque and force is combined and even represented by a single force at an offset. So this is how the final figure will come. So this is about one simple example which I have taken as a slider crank mechanism, or an IC engine mechanism, or a reciprocating piston mechanism. So this way, all the subjects can be looked at in the same or similar way, where simulation can be generated. Now we'll get into the next level in mechanical engineering. My colleagues will also talk about other branches, and they will demonstrate few experiments from each of these labs. I'll just get into, now I had started moving some item and I found out how much displacement, velocity, acceleration. Then I have looked at the force which is generated. Now I'm interested when there is a force which is moving up by changing with respect to time, what kind of vibration it can come. So I will look at a simple case of a cantilever beam. I'm just looking at a cantilever beam. This is a flash animation, hence you need to enable flash. I had already done it on my browser, hence it is coming. Otherwise, if you are doing, you need to enable flash. So this is a cantilever beam. I'm interested to see whether what happens when I change some parameter. The first thing I'm going to change is the damping factor. So this, I'm sure even electrical, electronics, and radio frequency people who are working RF also will agree with me on this. This looks very similar to what we do in an RLC circuit. You look at the way in which the things change. And I can also change the mass. N mass can be changed. The cross-section, in fact, the cross-section can also be changed. These are standard cross-section, which is mechanical engineering and civil engineering uses. Suppose the student want to do it for their own cross-section. On an examination paper, they have given area and IXX. They can also input that value and see whether their answers are right. So this is about moving from kinematics, dynamics to vibration. So let us see one more experiment wherein a single degree of freedom system with a forced vibration. If I am forcing this system to behave the way in which I want, how I should be able to look at the system. I'm just looking at, if I'm just allowing this to move, how things vary. Now I can change the stiffness and keep varying, or I can even change the frequency and see whether how the system responds. Remember, I'm changing the input frequency now. You can see how values are changing. Each of this value, I can keep on changing the value in such a way that it goes to something like eta value up to 0.1. It will take some time to reach there because you can see the increase in value. I'll just enter the value directly. It is 60. You can see when it is coming close to its natural frequency, how the system is behaving. I'm just increasing it further. You can see what happens to this. Now, at this, I'm also interested to see what happens when I change the damping. So I'm going to change the damping and see how the system is going to behave. You see the graph which is plotted here. And if you have this kind of facility in a normal classroom, I'm sure we should be able to provide experiential learning in our in-person classroom. And the same can happen online classroom also. So you can see how each of these moves. And you can also see how the phase angle, magnification, at what way the damping influences the system. So from here, we'll move on to another experiment, which is an 2 degree of freedom system, so that I can give you a little more complexity to demonstrate. So this is a 2 degree of freedom system. So what we did is we took a slider crank or an engine mechanism. We tried to understand how the piston is moving with respect to the rotation of the crank. And then we looked at the piston movement. How do I look at the velocity? From velocity, we found out the acceleration. And when we had acceleration acting on the mass, we looked at the dynamic force. When we said we have a dynamic force which is changing with respect to time, dynamic force is that is changing with respect to time, we will have vibration. And now this vibration we are looking at on a cantilever beam, we looked at the vibration. Now we are looking at if on a vehicle, if the tire M2 is moving up and down, but M1 where the people are staying or sitting should be able to make sure that they are comfortable. How do we do that? So just look at this, and I'm going to change one parameter. So here, remember earlier how it was moving. Now it is on the opposite direction. If 2 degrees of freedom, if I'm able to do it like this, I should get one point somewhere in between in such a way that I should have no movement for my M1. Look at this. whatever be the road condition M2, I will be able to make M1, which is almost stationary. So this can be looked at a 2 degree of freedom system. Of course it is, and with a lot of assumption, we have reached this condition, but this allows the students to learn how to choose corresponding stiffness and mass, and what kind of combination can help them to get a better suspension system. This is one way, or it can also be looked at 2 degree of freedom system to understand how tuned vibration damper behaves or works. So now we have looked at few things in simulation based. Now you can always say simulation is all right, but you would like to do an actual experiment. Is it possible in virtual lab? Answer is yes. So we are able to provide you an answer for doing an actual experiment. The previously done simulation experiment, a cantilever beam or a fixed beam, we'll do the same experiment on a real time and see what kind of data it provides. This is an actual experiment. And after doing that actual experiment, I had a fixed beam which is held at both the places. I'm just pulling it down and leaving. And this is the data which I get. This is not a simulated value. It is an data coming from the sensor when an actual experiment is conducted. Students should be able to download this information and analyze and find out a lot of information from the domain. I can do this multiple times, or 3 times is what we are allowing now, and or 5 minutes for a student. And here there is no login. It is, you can see the second data. So data 1 and data 2, I should be able to do 3 times. The third time data, this is the data which I am getting. So all the options for me, experiments, number of times experiment I could complete is done. So data 1, data 2, and data 3. You can download all this data, do analysis, and find out how this beam is behaving and what are the properties. Now, this did not have any things to change, a parameter to change. Let us look at another experiment which is remotely triggered. It's a simple pendulum experiment. I'll just connect first. I'm already in the queue. That means somebody else is using this. So it will take another 4 minutes to release. That means one student is already using it. So I won't be able to demonstrate until the student finishes his experiment. So let me just wait. It will take, if the student is doing, we should come to know, because this same website is available for throughout the world. Hence, there will be a lot of students doing it. I understand the student has left. So this is the experimental setup. This is a video. Now I'll just trigger first. So just look at the video. Here you should be able to see the experiment getting triggered. So you can see the experiment got triggered and the data has come. So when a simple pendulum moves, how the movement is and what happens when there is more energy consuming term, all that can be identified from here. So now I'll change the length and see whether I should be able to get another data. So here there is one parameter we are going to remotely change. So it's a physical experiment where actual setup is going to be, you can look at this green position, it will be moving up. This is moving up. Now I have reduced the length. Once the length change is over, I can trigger again and find out what happens when length changes in a simple pendulum, what kind of variations comes. Variations comes. So this is the varied length, and you can see the experiment. So let us see the data. You can see how the first data and second data, how different it is. So as the length changes, there are something which is going to change anyway. It is not a domain specific activity we are looking at. Hence, we don't need to dwell much on that. So this is another version. So we have seen now a simulation based experiment and a remote triggered based experiment. My colleagues will be also explaining different other kinds of experiments. And Those who are looking for video tutorials, we have video tutorials here, and wherever possible, it has been given as a complete LMS. Theory, procedure, self-evaluation. Before the experiment is conducted, you can do a self-evaluation, what kind of understanding you have presently. Then a remote triggered or a simulation based. Then I have a set of assignments, references, videos, and last a quiz wherein after doing this experiment, what kind of improvement or delta X has come. So this gives a motivation for the learner to evaluate, self-evaluate before the experiment and after the experiment, what kind of change in understanding has been attained. So this can be used for normal classroom purpose, in-person classroom. That is what we have been doing before COVID. And during this COVID period, those who are taking online classes can use the same website and demonstrate and ask the students to do these experiments, take a screenshot or convert that into a PDF and ask you to load back or back into your LMS if you are using a learning management system. Or it can be submitted as an assignment and see whether it can be used. Or after the COVID or our normal classes starts, this can be used as a flipped mode of education or learning, wherein whatever you want to ask the student to learn or read and come, you can ask them to read the basic theory, few procedure and do some experiment, come back to the lab or come back to the class and give them tougher assignments in presence of the teacher, so that the teacher will be able to help the student when they are doing an actual problem solution, a solution to the problem. So these are the three ways which we are looking at for this virtual lab to be used during the this period. That is in-person classroom, online classroom, and a flipped mode of classroom. And those are looking for conceptual clarity, whether they are looking for a job interview or from the job, shining in the job, or maybe changing the job. The same website and the virtual lab can be very well used. So what I have tried covering here is the basics of how, let me just stop my screen sharing. So what I have just covered is what is virtual lab, how one can use it for in-classroom activity as well as a flipped mode of learning, and plus how it can be used along with our normal material, and then how the learning management system can be used when you are doing an experiential learning. With this, I would like to stop here and my colleagues will take over and start doing specific experiments. Now I will push it back to, I think it is Shraddha who will be taking next. Shrestha?
Yes, sir.
Yeah. So
Good morning, sir. Is my voice is clear and?
Yeah, I'm able to hear you.
Okay, sir. Yeah, thank you. Yeah, so very good morning to you all. Myself, Shrestha, working as Senior Research Fellow at Center for System Design and LTCoE Surathkal. So right now you got to know what exactly is virtual lab and what are the different types available, like mainly under mechanical domain. So let's now quickly see the different labs available under electronics and communication domain. So I'll be taking you through few of the labs available under electronics, through few of the labs available in different domains. So I'll be sharing my screen now. So is my screen is visible? Is my screen is visible? Hello?
Yes, it's visible.
Yes, now it's visible. Yeah.
Hello. Okay, sir. Yeah, thank you. So now you're all familiar. Okay, sir. Yeah, thank you. Fine. So now you're familiar with this particular website, right? So this is actually website for virtual labs. So we know what are the objectives. Okay, we just already explain what is the philosophy behind the selling features and so on. So these are the broad areas where virtual lab.
Maybe there is some network issue. She'll join it again. Hello.
Hello.
Yes, you're audible now.
Okay, sir. Yeah, thank you. Fine. So you can see my screen now.
Yes.
Is the screen visible?
Yes, it's visible. But there is distortion in your audio.
Hello. Okay, so yeah, thank you. Fine. So these are the different labs available. So few things to note on. Okay, so yeah. So few things. Okay, sir. Just then give me just a minute. Hello.
Yes.
Sir, is my voice is clear now?
Yes, now it's clear.
And can you see my screen?
Yes, yes.
Okay, sir. Yeah, thank you.
Thank you.
Sorry for the interruption. Fine. So few things to note is the basic structure basically. So we have different domains, then are the different set of labs, then are the experiments within that. And other thing is we like some of the concept we might be studying under different domains. Like, for example, logic design, if I say, people from electronics and communication might study, people from CS people, they also study, and other things. So those concepts might be available in different domains. So the basic criteria is we need to explore different domains, different labs available, and pick whatever concept is suitable to us. And one more thing is, some of the concept might be demonstrated under multiple labs. So whichever is convenient to us, we can pick those. So now let's quickly see a few of the examples available. So when we say labs, from very basic topic to very advanced one, you can see the varieties. So to start with, I'll go with basic electronics lab developed by IIT Kharagpur. So a concept under electronics, we all will be knowing, irrespective of the branch. So to say is Ohm's law, right? So these are the experiments available under basic electronics lab. So first three are theoretical ones. So Ohm's law we are all familiar with. So when we take an experiment for Ohm's law, what we do? We take a component of particular value, do the connection, vary the input parameter, that is input voltage, note down the current readings in steps, then plot VI characteristics. So this is how we perform this particular experiment. So a similar flow is followed over here as well. So I'll directly go to simulation. These are the variations available. So let's see just one. So this is the simulator window, what we have for Ohm's law experiment. So this is the basic circuit which we usually take, right? So this is the basic brief instruction, brief procedure given. Here be updated. Here is the graph area where we will plot VI characteristics. Okay. To start with, we know we need to provide the resistance value, some arbitrary value. We can fix it over here. Then is to vary the voltage from minimum to maximum. Here I can vary the voltage. So with each value of DC volt, we need to click add to table. You can see the table getting updated. Then we need to click on plot button after taking 5 to 6 reading. You can see VI characteristics being plotted, which we can take a print out and keep it for a further reference. So if we want to perform the experiment for some other value of resistance, then we can clear entirely, do the experiment again, take one more plot and keep it for a future reference. So this is how basic Ohm's law has been implemented under virtual lab platform. So to move next, we, irrespective of the branch, we might be doing a project. So that might include a small electronic circuit or something. So at that time, we require to solve that circuit to find maybe current in a particular branch or so on. So is there any way to rig up a circuit and apply the concept to find the basic parameters required? Yes, we few labs for that. So I take you through two labs where one lab deals with a fixed circuit where we can only change the parameter and get the output observation set.
Beryl, can you hear me? I think she has some internet problem. So continue.
Yeah, we can hear you.
Yes, sir. I think she has some internet issues. She's back, I guess.
You can tell her to stop and you can take over.
Yeah, I'll just
Hello.
can you hear me? Shrestha? Hello.
I'll request Shrestha to stop for a while.
Yeah, Akib, can you take over? Yeah. Hello.
Shrestha, you can continue later if you want. I think you have internet issues. So I'll just
Yeah.
start now.
Yeah,
You
yes,
can
Akib.
maybe continue after Hekle also.
Yeah, I think
Okay.
Akib, it's better you continue.
Okay. Fine. Good morning, everyone. I'm Akib Nadaf, and I'm a junior research fellow in Center for System Design. So I'll try to continue where Shrestha left off, and I'll do some experiments in electronics communication. Slowly, we'll transition to electrical engineering experiments. I'll be sharing my screen now. Hope you'll be ready. Yeah. Is green visible? You can just put the feedback in that box. So you get know.
The screen is visible. Go to the experiment.
Is this resolution? What's up? Is this visible though?
Screen is visible, but you need to open
Okay.
the experiment.
Okay, I'll do that. Is it right?
അവിടെ ഈ NIT-യുടെ
Okay, got it.
അമ്മാരി അടുത്ത ആളാണ് അടുത്ത ആളിനെ കേട്ടില്ല
Hey, it's proper. No audio.
Yeah, your audio is coming, but slightly broken.
No, hello. Can you hear me?
I can hear you, but your audio is not very.
Audio is not right. Can you hear me now? Okay. I hope you can hear me. If some problems, you can just let me know in the chat box.
Go ahead and show the lab. Open the lab and show the lab.
Okay, sir.
Keep all the labs open.
So, you will have introduction to what the lab is about.
Very
And
poor
we'll have
audio.
some experiments. So this is a basic introduction of what the yes sir.
Very poor audio. Just see whether you have a standby connection.
There's a problem in the audio.
Hello. So can I try presenting once? Yes, Akib. Hope my network is stable now.
Okay, can I okay.
Yeah, it
Stop my
stops with
right.
screen. Yeah, I'll take over.
I stopped.
So is my voice clear and audible now? Hello?
Shrestha, you have something else is happening. It is not just network issue because
Hello?
Actually, KVG sir's voice is proper. It's not breaking. So my voice was breaking, or what?
Now you are okay. But when you are showing the
Hello.
Shrestha, your voice is breaking.
I think when sharing the screen is taking too much bandwidth, sir.
Yeah, so you need to keep all the labs tab open. Do that.
Yes, sir, my labs are open already. Shrestha is not there, I think.
No, you can
Or
share.
shall we try someone else, sir? You can tell or Aishwarya Hegde.
Yeah, ask Aishwarya to take over.
Okay, okay, sir.
Good morning, everyone. I hope I am audible.
Yeah, Aishwarya, you are audible. Show your face first, then go to lab.
Yeah. So I'll be presenting on some of the simulation-based lab in civil engineering. I'll try sharing the screen. I hope the screen is visible now.
Yes, it is visible.
Yeah. Okay. As you know, to access the simulation-based lab, we have to go to wheellab.co.in, and there, based on your discipline, you can go to the experiments related to your discipline. So we'll go to the civil engineering labs. As you can see, the labs developed under civil engineering discipline, and the institute that is developing that has also been shown. So we'll be seeing one of the experiment in strength of material lab. So the format of the labs remain the same. There is introduction, then there is list of experiments, where you can see the experiments that are there in this subject. Then there is target audience. Basically, it will tell which are the students that can use these labs. Then there are course aligned, that are the subjects which can be, for which subjects these labs can be referred. Then there is a section called feedback. So let's go to the list of experiment and see one of the experiment. We'll go and see the isoid impact test. Again, the format remains the same. There is theory. Theory will give the basic information of the experiment. Then there is procedure. Procedure, it's not like the procedure, it should not be confused to the procedure of the experiment, but it is how to conduct the simulation. So where exactly you have to click on the simulation. Then there is self-evaluation. There is a set of quiz questions which the students have to take up. Then there is simulator, where actually you'll be doing the experiment, and then there is assignment questions and quiz questions. So we'll directly go to the simulator. As you can see, the objectives and the apparatus used are defined. So we'll click on next. So in the first case, what we'll be doing is we'll measure the loss of energy due to friction. So we'll be pulling this lever, and that time the energy, the loss of energy due to friction will be recorded. So it is 4 joule. So once that is done, in the second step, the user is given an option to select the type of specimen. So I'll be selecting the mild steel specimen. So once I select the mild steel specimen, the dimensional specification of the mild steel specimen will be given here. Then click on next. Now the specimen will be placed in the anvil position. So we'll be placing the specimen perpendicular, and the notch will be facing the hammer. So I'll click on next. Now for the first trial, we have kept the specimen in the anvil position, and now we'll be pulling the hammer. The hammer will strike the specimen, and in the meanwhile, we'll measure the total loss of energy during transit of the hammer. And then we'll calculate the energy for failure of the specimen, that is 44 joule minus the 4 joule, that is energy loss due to friction. So click on next. So the calculation of the trial 1 will be given here. Click on next. Now for the second trial, one more new specimen is taken. So you can see the dimensions of the new specimen you have taken. Now I'll be pulling the lever. So for a second trial, the energy loss during transit of the hammer will be shown. Now for the second trial, we'll finally calculate the energy for failure of the specimen. Again, for third trial, we'll take one more specimen and the dimensions of that specimen will be given. Click on next. Now we'll allow the hammer to strike the specimen. Note down the energy loss during transit of the hammer. So once you're done with the 3 trials, there will be a table showing the results of the 3 trials, and we'll calculate the average energy for failure of the specimen. So here the average of these 3 values is 45.33 joules. So this was one of the experiment in strength of material lab. Now going back to the list of experiments, in strength of material, there are experiments related to the impact test, that is ISOD and CHARPY. Then there is direct shear test. Then there is hardness test. Then there is tensile test on mild and cast iron. And then there is compression test on mild steel and cast iron. Also there is torsion test on the mild steel. So this was a brief introduction on the strength of material lab. So going back to the main civil engineering browser, there is a fluid mechanics lab. In that there are 2 labs, fluid machinery labs and fluid mechanics lab. So going to the fluid machinery lab, if you click on list of experiments, there are about 7 experiments. So we'll see the performance characteristics of Francis turbine. So here, as you can see, the aim is defined and there is theory. The format remains the same. But these are the new labs hosted by IIT Bombay. So we'll directly go to the simulation. So in the simulation, there are 2 parts. That is there are 2 options. That is Francis turbine under constant head condition and constant speed condition. So I'll select the constant head condition. So here, as you can see, the objectives are defined, the apparatus used are defined. Then there is a section called description where some of the important parameters are defined. So I'll click on next. So the first step is to start the pump. So I'll be clicking on the green button. So since this is a constant head condition, the user is given an option to select the head. So from the drop down menu, I'll select the head as 11 meter. So I'll click on OK. So there is a question, selected head value is constant throughout the experiment, say true or false. It is true. So these questions are added so that the experimentation does not become monotonous, and also the students are also to check whether the students are focused on the experiment. So the head is selected as 11 meter. I'll click on next. Now we'll open the inlet valve to keep the pressure constant and to set the head as 11 meter. So next. So in the first trial, we'll not be applying any weight on the pan. And for that, we'll calculate the corresponding torque value. So as you can see, there is the formula to calculate the torque. And the readings are also given. So based on the formula, we'll calculate it and click on check. In case the answer is wrong, the correct answer will be displayed. Now we'll be inserting a tachometer to note down the speed of the motor. Since it is constant head condition, the speed will vary for every trial. So for the first trial, the speed remains 1750 RPM. So click on next. Now take the hook gauge reading, that is the final and the initial reading. And then calculate the head of the water, that is final minus initial, then also calculate the actual discharge. So the formula to calculate the actual discharge is given here. So based on the formula, we'll calculate the actual discharge. In the formula, there are some constant parameters which are given here directly to the students. There's a question. Francis turbine is it's a reaction turbine. So click on OK. So next, under the Francis turbine constant head, addition of weight increases the speed. Say true or false. It is false. So for the trial 1, we'll be calculating the parameters like input power, output power, efficiency, that is output power by input power. Then there is unit power. Then we'll calculate the unit speed, that is the formula to calculate the unit speed is n by root h, where h is the constant head that we selected. Then we'll calculate the unit discharge. So all these parameters are calculated for trial 1. We click on next. Now again, you'll increase the load on the weight on the pan. So we'll be applying a weight of 2 kg. For that, we'll calculate the corresponding torque. So the formula is given. Now in the second step, we'll be inserting the tachometer to measure the speed of the motor. So for trial 2, the speed is 1630 RPM. Again, note down the hook gauge reading. And eventually calculate the actual discharge. Head of the water is calculated by, as I said, it is final reading minus the initial reading. So H is equal to final hook gauge reading minus the initial hook gauge reading. So click on next. So for trial 2, you'll calculate the output power, that is 2 pi nt by 60, where n is the speed of the motor, T is the torque, and then you'll calculate the unit discharge. Now for trial 2, again you'll increase the weight on the pan, so it is about 3 kgs, and calculate the torque. Now insert this tachometer and note down the speed. So for trial 3, it is 1580 RPM. So click on next. Again for trial 3, you'll calculate the actual discharge. So using the formula, we'll calculate the discharge. Francis turbine is located between high pressure water source and the low pressure water exit. So click on OK. So for the last trial, we'll calculate the parameters: input power, output power. Then there is efficiency, that is output power by input power into 100. And then there is unit discharge. So once all the 3 trials are over, you'll stop the pump by clicking on the red button. So we can increase the number of trials by increasing the weight on the pan. And finally, once all the steps are over, we'll plot the graph of efficiency versus unit speed, unit power versus unit speed, and unit discharge versus unit speed. So this was one of the experiment in the fluid machinery lab. So going back, so we'll see the fluid marine structure lab. So go to list of experiment. So we'll see the slump test. So in the slump test, the aim is defined, that is to determine the workability of the concrete mix. Again, you can see here there is theory. The template remains the same. So we'll go to the simulation. The objective is given, that is to determine the workability of the concrete mix. Then there is apparatus used. So we'll click on next. The first step is to measure the dimension of the slump cone and then calculate the volume of the slump. So the formula to calculate the volume is given here and the dimensions are given. Then there is, so once we calculate that and enter the answers, we'll know what is the volume of the slump cone. So now there's a question. Difference in radius of the slump cone from bottom to top is, it is 5 centimeter. So click on next. So in the second step, we'll be fixing the mixed proportionality ratio. So it is about 1:2.7:4.2. So based on this mixed proportionality ratio, we'll calculate the cement content. So the formula is given there. So then we'll calculate the quantity of fine aggregates. And then we'll calculate the quantity of coarse aggregate. The formula is given there. Then we'll also fix the water content that has to be added. Once the calculation is over, we'll measure these quantities using a weighing machine. Now we'll take about 1.6 kgs of cement and then followed by 4.3 kgs of fine aggregates. And then we'll measure the coarse aggregate that has to be taken. It is about 6.7 kgs. So once all these parameters are calculated, we'll measure the water that has to be taken, about 0.67 liter. Mixed proportionality used in the experiment is 1:2.7:4.2. Okay. So click next. Now you'll mix the fine aggregate, coarse aggregate, and the cement using a trowel and form a dry mix. Quantity of cement used in the experiment is, we took about 1.6 kgs of cement. So click on next. Now we'll add the measured quantity of water to the dry mix and mix it using a trowel. Quantity of fine and coarse aggregate used in the experiment is, it is about 4.3 kg and 6.7 kg. So click on next. Now we'll fix the slump cone to the horizontal base and then add the concrete mix in 4 layers to the slump cone. So when each layer is added, the layer is tamped for 25 times using a tamping rod. So compaction is done by tamping the concrete mix using a tamping rod. Now we'll add the second layer of the concrete mix to the slump cone. Again, the concrete mix is tamped for 25 times. The compaction is done to remove the air voids. Now the third layer of the concrete mix is added to the slump cone. And it is tamped. So we'll be adding the fourth layer, that is the final layer of the concrete mix. And tamping it. The purpose of tamping is to obtain uniform compaction in order to avoid voids. Say it's true. So click on next. Now you'll remove the excess amount of concrete that is found on the slump. Each layer of the mix is tamped for 25 times. So click on next. Now you will detach the slump cone from the horizontal base and move it in the vertical direction. And measure the difference in the height of the slump cone and the slump using a measuring scale. So it is about 18 centimeter. Height of the slump cone is, it is about 30 centimeter. So click on next. So for the mixed proportionality ratio we fix, the slump cone is about 18 centimeter. So this was one of the experiment in the marine structure lab. Then there are experiments related to environmental engineering. Then there is transportation engineering lab. So we'll see one of the experiment. So click on list of experiments. As you can see, there are about 8 experiments. So we'll go to the CBR test, that is California bearing ratio test on soil. So directly to the simulation. So the objectives are defined, the apparatus used are defined. So click on next. So in the first step, we'll be taking the soil in the sieve of 20 mm. And the whole sieve set is kept in a mechanical vibrator and it is vibrated for about 10 minutes. So we'll remove the sieve set from the mechanical siever. Now the soil that is passed through the 20 mm sieve is weighed using a measuring scale. And optimum moisture content is fixed, about 15 to 20%. Based on that, we'll take the water that needs to be added and mix it with the soil, the measured quantity of soil. Now, we'll keep a spacer disc and a coarse filter in the setup and attach a mold to it. The mold is well lubricated filter paper is used to separate the spacer disc from the soil during compaction. Say true or false. It is true. So click on OK. Now for this whole setup, the soil is added in 5 layers, and each layer is compacted for about by giving about 56 blows using a hammer of 4.89 kgs. So it is tamped by giving 56 number of blows. Now the second layer of soil is added to the mold and is tamped. So once the tamping is over, the third layer of soil is added. The compaction is done to remove the air voids that are present in the soil. Once the third layer of soil is added, a collar is attached to the setup. And now the fourth layer of soil is added. The final layer is added and it is tamped by giving 56 number of evenly distributed blows using a hammer of weight approximately 5 kgs. Now once the tamping is done for the final layer, the collar is removed. It's detached from the setup and the excess soil that is present on the mold is removed. Why scratching is done between each layer? For bonding between layers. So click on OK. Now the mold is attached from the setup and it is inverted. The filter paper is removed and the spacer disc is removed. Now you'll be placing a new filter paper and the mold is placed on that. Here we'll be attaching a surcharge weight on the mold. Which disc is placed on the top of the mold? It is surcharge weight. So click on OK. So click on next. So the whole setup is placed in a testing machine, penetration testing machine, and for every 0.5 mm penetration, the proving ring readings are noted. So click on OK. So as you can see, for every 0.5 mm penetration, the proving ring readings are noted. And for this reading, we'll calculate the corresponding load and the axial load. As you can see, the formulas are given here. Click on check. In case you want to get the corresponding values of all the readings, you can get it in a tabular column. So now we'll plot a graph of axial load versus penetration. So click on next. So in CBR test, we need to calculate the CBR value at 2.5 mm penetration and at 5 mm penetration. So once that is done, to calculate that, you can refer the graph here. Then there's a question, IRC recommended value for sandy soil. For sandy soil, it is 5 to 40%. So click on OK. So as you saw here, the answers are within the specified range. So the soil can be used for pavement construction. So this was one of the experiments. These are some of the civil engineering labs in the virtual lab. So I'll be showing the RT labs for strength of material. So to access that, we have to go to rtlabs.nitk.ac.in. So here in RT labs, there are two options, that is vibration labs and strength of material lab. The vibration lab is already shown. The simple pendulum was demonstrated. So in strength of material lab, these labs are a destructive type testing lab. So for this, to access these labs, you need to book an appointment by mailing us. Also you can send your own specimen for testing. So we'll see the torsion test on mild steel. The format remains the same. Here, instead of simulation, you'll go to remote triggered. So in this strength of material lab, each person who accesses this lab will be given a time slot of 10 minutes where he can test his specimen and also see the live recording. So I'll be choosing the external network. So we'll see the live stream. So the live stream, what you'll be seeing is, will have a lag of 10 seconds. So you can see here the torsion test, the mild steel specimen is placed here. And this is the fixed end and this is the rotating end. So we'll go to connect. So I'll start. So my time slot, that is 10 minutes time slot is given here. So I am connected here. In case someone else has already got an access, you can see the experimentation. So I'll give trigger. So as I give trigger, the readings will be shown on your screen. That is torque versus angle of twist. So we can see I'll copy the video URL. Then there is an option to select the, so let me disconnect and try again. Connected, let me trigger. Maybe there is some technical problem which we can see later. So this was my demonstration on the civil engineering labs. I think now Shrestha can continue.
I think I'll be taking over now. Am I audible? Can you give me a feedback? Okay, is it breaking? Okay, now we're fine. Like I have switched off the video now.
Beryl, it's slightly better, but it's still breaking.
Hello, Aishwarya. It is still breaking, yeah?
Beryl, sir? Hello?
Shrestha, can you go ahead?
Yes, sir. Is my voice is clear now?
Yeah, presently voice is clear. You just
I'll try sharing my screen, sir. Let me check. Is my screen is visible now?
yeah, now your audio is also okay. Go ahead.
Okay, sir. I'll try to go ahead now. Fine. So as I already said, I'll be starting with basic electronics lab itself, as I already showed. So let's see one of the simulation window, what we have for basic electronics, right? So this is a Ohm's law experiment. simulation interface what we have. So to perform according to the instruction to go with, first thing is we need to set the resistance value. Next, we need to vary the DC voltage from minimum to maximum. So for each value of DC voltage, we need to click add to table, take some 5 to 6 readings. You can see the table getting updated over here. So once we take few readings, we can click plot button. So we will be getting the VI characteristics plotted in the graph area. So which we can take a printout of this and keep it for a further reference. So if we want to repeat the experiment for some other value of resistance, then we can clear the entire values. Then we can set resistance value to something else, redo the experiment, get one more VI characteristics and keep it for a further reference. So this is how basic Ohm's law has been implemented or demonstrated under this virtual lab platform. So to move next, we might be required to implement or to find out a current in a particular branch in a project. What we do, project might include a very complicated activity from mechanical domain or some other domain, but a part of it might be related to electronics field. So there we may rig up a circuit where we might be confused to find what exactly is the current flow. In that case, we have few labs available where we can, for a particular given circuit, we can vary the parameters, find the output values. If not, there is one more lab where we can rig up our own circuit and find the parameters. So we will see two experiments for that from two different labs. One lab I would like to take you as analog signals network and measurement lab developed by IIT Kharagpur. So these are the experiments available. So let's see one of the experiment, maybe on Thevenin's theorem. So this is the Thevenin's theorem experiment what we have. So I'll directly go to simulate the window now. So this is the simulator window we have for Thevenin's theorem. So here is the same circuit given. Here we cannot change the circuit. We can only change the value of resistance as well as voltage. Yeah, here is a detailed procedure given. Here you can see case 1, case 2, case 3. So case 1 is to solve this circuit using normal circuit solving procedure. Case 2 and 3 deals with Thevenin's theorem. Here is a table to be updated. Fine. So to start with case 1. So you can see two switches given, S1 and S2. That is to control the input voltage as well as load to the circuit. Okay. When I say a normal circuit, we will be connecting power supply as well as load. So S2 should be load now. So once we keep that, we need to click simulate button to find this load current. Yeah. So next is case 2A. It is to find the Thevenin voltage. 2B deals with to find Thevenin resistance. Okay. We know to find Thevenin voltage, we need to remove the load. So we can select power over here or intermediate over here. So if we do something wrong connection and if we click on simulate button, we will be getting an error message. So which we can redo the connection and perform the experiment. So here now I need to remove the load. So my S2 should be intermediate. I got the Thevenin voltage. So case 2B is to find Thevenin resistance. So we know to find Thevenin resistance, we need to short the power supply. So S1 should be short. S2 should be power. And if I click on simulate button, I'll get the Thevenin resistance. So to find the load current using this Thevenin's theorem, we have VTH, we have RTH, we have simplified the circuit. So if I click on simulate button, I'll be getting the load current. So to compare, if my load current obtained using Thevenin theorem and with case 1, if it is matching, we need to fill data to the table and check. So here you can see the table getting updated. So this is load current we got from case 1 and this is using case 2. Okay. And using Thevenin's theorem. So this is the first set of observation we got for this particular R and V value. So now we can change the voltage value. We can change the resistance, each resistance value, and then redo the experiment and get the next observation sets. So this way, this particular experiments under this particular lab is being demonstrated. So I already said there is one more lab where we can rig up our own circuit. That is, we have a lab called Virtual Electric Circuits Lab developed by Amrita Vishwa Vidyapeetham. Okay, so when we go to that lab, these are the experiments available. So again, we will go to Thevenin's theorem. When I say the theorem, it is basically to reduce the complicated circuit and find the current in each branch. Okay, so one thing to note regarding the labs developed by Amrita Vishwa Vidyapeetham as well as IIT Kanpur is, when we try to access simulator, it will ask for login. Okay, this is just to track the number of users using this particular lab. So you can create your account and using your login credentials, you can always access the simulator. So now I'll log in just to demonstrate the lab and show you how you can use this. Okay, so once when I logged in, this is a simulator window. It again works on Flash Player plugin. So I need to enable that in my browser. So once I enable, I'll be getting the simulator window. So here is a place to rig up my circuit. Here is to change values. Here are the components available. So using these components, I can rig up my circuit. Okay. So for example, I'll click on the component, drag and place it over here. Then I'll be connecting each component using wires. So once I complete my entire connection, I can measure the parameters using these measuring devices. So if my connection is right, it will be highlighted in black color at the endpoints. So now I can change the visuality. So I can change schematic over here. I can click on show values to show the individual component value. Then I can click on each component, change its value and so on. So to measure the parameters, I can click and drag it over here, place it on the wires to measure the current. For example, here, since the circuit is open now, I have 0 ampere as a current. When I complete my circuit, the respective values we will get. Okay, so this is how we can rig up our own circuit and apply the concept. Fine. So to move next, you might be from some other domain, but you might be using a small microcontroller, maybe say 8051, very basic one. So you need to know how it is working, how to interface a basic LED with a microcontroller. So for that as well, we have a lab. We have a lab called 8051 Microcontroller and Applications Lab. It is with a suffix new, that is, it has been added recently to this particular website. So I need to click explore button now. Here, these are the experiments available currently. So let's see one of the experiments. So it is first experiment deals with interfacing microcontroller with display devices. So here we have display devices, LED as well as 7-segment display as the display devices available. So this is the simulator window what we have. Here is a small editor where we can write our code and check if it is working fine. If not, for understanding purpose, we can copy sample codes available and do the modifications. So I'll copy the code. I'll paste it over here in the editor. Here you can see the memory mapping when you debug code line by line. Here is to see the output. Here you can select the different ports available. This is to observe mapping in the pins. Fine. So here we have an option to run the code entirely or step-by-step execution also possible using this debug button. So I'll click on debug button. So with each click, you can see the code getting highlighted. So the current line will be highlighted in green color, next line in blue color. So here you can see in port 0, since in the code port 0 is used, I have selected port 0 over here. You can see P0 value over here as 79. That is the value in the current line. Okay, so now if I change the port, if I don't change port over here, and if I click on debug button, I cannot see the output over here. So this is how the working of interfacing this controller with the display devices have been implemented. So here we have set of questions to be answered where we can check our understanding level. So this is one particular lab available. Also, you might be requiring a latch or flip-flop to be used, or you might be required to know some of the basic IC working. So where it is available. So when I say electronics domain, we have a subject called Digital Electronic Circuits Lab or Digital Electronic Circuits, where we study variety of concepts, maybe starting from combinational circuit, encoders, decoders, multiplexers, and so on. So we have multiple labs available demonstrating these concepts. So I'll take you through maybe one of the lab called Digital Electronic Circuits Lab developed by IIT Kharagpur. So you can see the different concepts explained. So let's see one of the example, maybe the analysis of flip-flops, different flip-flops what we have. So I'll go to simulator. So here you can see part 1, part 2, part 3, part 4. So part 1 deals with SR flip-flop, part 2 with JK, part 3 with D, and so on. So here, if we see the simulator interface, this is the area to observe the waveform. Here is to provide the input. These are the connections. Here is the LED output indicators. So when we say IC connected, we know we should provide VCC and ground. So we have two ICs. So we have two VCCs, that is VCC1 and VCC2. So I'll click over here to enable VCCs. Then I'll keep ground in 0 state. Once I enable both the VCC, I'll get control over this clock start button. So if we click on that, you can see the clocks running over here. So I'll stop the clock now. I can give the number of clock pulses over here. So what is this? So for each change in input combination, for these many clock cycles, I can see the output. So if I want to implement set condition, I can make S as 1. I'll keep R in 0 state. And if I click on clock start button, set condition of SR flip-flop will be implemented. So for 4 clock cycles, it will be executed and then the execution stops. So similarly, if I want to implement the other conditions, I need to provide the input, click on clock start button. So for these many clock cycles, you can see the output. Okay, so this is how flip-flop have been implemented. So other examples or other experiments under this particular lab follows a similar way. So also to move next, we have a variety of labs again. You can see over here. Maybe to show you one more different interface, I'll take you through one more lab called Digital Signal Processing Lab. So you can see over here. I'll go to list of experiments. So these are the experiments available under this particular lab. So let's see one of the experiments, sampling theorem implementation. So simulator is slightly different again. So here each step-by-step procedure will be given like this. So first step, as they say, is to click on browse blocks button. We'll be getting 3 blocks. So I need to click on each block, place it over here, then provide the specification, which I can change it later on as well. Then is a sampling block. I need to provide the sampling frequency. Then is a virtual scope block. This is to observe the output. Then I need to connect each block. So if my connection is right, it will be highlighted in black color. If the connection is incomplete, then it will be shown in red color. So this is a correct connection. Then it is black. If I do some wrong connection, you can see that an undo button is provided. So if I click on that, one connection goes off. So I can remove the connection and redo it. Finally, I need to click on virtual scope block to observe the output. Here we can again change the input specifications according to our requirements and observe the different cases of sampling. So basically, understanding different concepts, we can use these labs available. So these are the few different interfaces what we come across under the labs, what we have under electronics and communication domain. Yeah. So with this, I think and other labs, you can also find the concepts being demonstrated under a platform called New Lab Development, which is again the labs before putting to the main site. It will be available over here. So here we can click on Explore Labs. So over here you have 2 options. So approved labs are labs added recently to the main site. So the labs under development has to go through certain verification and then it will be added. So here also you'll be finding some more labs where some other concepts have been demonstrated. Okay. So with this, I would like to conclude the presentation from my end. So next I would like to hand over the session to Akib to deal with the electrical labs. So thank you. Akib, are you available?
Yeah, Shweta.
Okay.
Is the voice audible?
Yes.
Is it glitching?
No, now it is clear.
No, you can hear me clearly. Okay, fine. So I'll be sharing screen now. Shweta, after I start sharing my screen, just let me know if the audio is proper or not.
Sure, Akhil.
Yeah, can you see me now?
Your screen is visible.
Shrestha, can you hear me?
Yeah,
Yeah, it is clear now.
What about the audio?
It is clear. Yeah,
Even the
you can
audio?
go ahead.
Okay, then I'll start my session. So I hope you got the basic idea of how to go about the labs or not. Since Shrestha has already taken most of the labs under electronics and communication, I'll just jump to topics on electrical engineering. So let's start with electrical machines. We'll do all the basic things what we come across when we are in electrical engineering. So we'll be doing an experiment on magnetic field behavior in a single coil. Here, it's the experiment is as simple as proving that there's a magnetic field generated by a coil when an electric current passes through it. Um, so but we're doing it in a fashion which is more experimental. So I think when we do the experiment, normally we just use a current coil conductor and see the deflection in a compass needle. Here, what difference? How we're doing it differently is instead of using a this thing, the compass needle, we're using a Hall effect sensor so that we can see the output and see what kind of magnetic field is generated in it. So first, I'll start with the connections. The red thing, what you can see. So I'll just do the connections. There are two of this experiment. It's experiment 1 and 2. The only difference is first giving DC supply to see what field is generated by DC signal. Then we'll try and give an alternating input to it and see how the field is. So I've done the connections. The connection is simple. I've given DC input to the coil, and the silver color ring you can see that's a Hall effect sensor. So I've connected it to the oscilloscope. So I'll check the connections. I'll click here to check if the connections are all right. It says the connections are right. I'll click on OK, and I'll switch on the MCB, the main circuit breaker. So once that is done, I'll give input voltage to it. So yeah, so once the input is given, you can see the voltage slowly rising because I didn't turn it on with a switch. I turned it on using a meter. So since it's gradually increasing, you can see the gradual increase in the graph here. Parallelly, you can see the output of the Hall effect sensor, and you can see the south pole is here, the north pole is here. We have the knob to change the polarity of the supply. So as you can see, the direction of the current here is I can see in a way it's clockwise. So this arrow is pointing here. So once I change the polarity, you can see both the direction of current and because of that the magnetic field. Here in this graph you can see the change in the direction of the current. So that's how it goes. Now there are little advanced things. You can check the harmonics. So um, the harmonics of the sine wave in the system are displayed here in this oscilloscope. You can see that the strength of the harmonics reduces as you go up the scale. So that is the first harmonic. If I want to check the fifth harmonic, you can see the amplitude is very low, and if I want to check the ninth harmonic, it will be even lower. So that was for part 1 of the experiment. So we'll just see how this experiment will vary when we are giving AC supply instead of DC supply. So I'll go to experiment 2, and once it loads, I'll quickly do the same connections. The connections remain the same. So I've given the input, AC input, and I'm connecting the Hall effect sensor to the oscilloscope. I'll check the connections. It says the connections are right, and then I'll click on OK. Switching on the MCB, I'll give voltage. sure why this is happening. Uh, Looks like there's a glitch and my setup is lagging. So it's all right, but the basic difference will be when you're using an AC signal, your field will be sinusoidal along with the input signal. So that's it. Right. Oh yeah, the voltage has come up. I'll try to give some frequency. Okay, never mind. Sorry for the setup. So we'll try and do some other experiment. There are experiments ranging from electrical machines to PLC setup. So those are PLC lab separately. I'll be doing an experiment on electric. So once we go there, I'll go to list of experiments. And I'll go to application of PLC. Here, there are simple setups on showing application of PLC. So how we can use programmable logic control to open and close the garage door, or if you want to change the direction of an induction motor. There's a interesting experiment on how you can use PLC to fill a current. So we'll just see how it goes. There are theory, procedure, and everything. So it tells us about what are the things required. So what are the sensors and actuators we'll be doing, and how a ladder level programming basically works in a PLC. But I'm going to skip that and go ahead for the solution. Sometimes we get this error called add-off flash player is blocked. You can just click here and you can see the player is blocked. So you can just allow it. If you do this, it will start working. Yeah. So we have set here. I just reloaded page. So yeah, the simulator should be up in a second. Yeah. So we have the simulator here. On the left side, we have the entire setup. If you look closely, I'm going to ignore the right hand side now. So if you look closely on the left side, we have it's a simple setup with two sensors and two actuators. So basically, it's a pair of sensor and actuator. On the bottom side, we have a proximity sensor and a motor. And on the top side, we have a level sensor and a solenoid valve. So I'll just start the setup and see how the system works. I'm clicking on start. So as and when the container approaches here, the proximity sensor senses that the container reaches and it stops this motor. So we'll see how it happens. So yeah, the motor has stopped the conveyor belt, and now as soon as it stopped, the solenoid valve will open, and the container filling process will start. Once the container is full, the level sensor will detect it, and the solenoid valve will switch off. And then there's a small timing circuit. Then the motor will start again. So on the right hand side, we can see the parallel ladder level programming happening for the entire setup. And you can also pause the simulation at any time and see the logic level of any sensor or actuator. So the straight lines basically convey the NO switches, and the proximity sensor here will it's basically a NC switch. So apart from that, the actuators are shown. The actuators are shown in red or green, showing they're running or not. So yeah, so I'll just start the setup again to see the difference. The motor is running, the system is running. If the container is full, so it basically tells you in a simple way how a PLC system works using sensors and actuators. Now, there are various experiments on high voltage lab and other things. So I'll go back to electrical lab and show an experiment on induction motor. So, it's an experiment on no load test. So I'll just go there. Since usually the electrical machine experiment requires a lot of wiring, it takes time to set it up. If you go to the experiment, you can see the experimental setup. So this is our setup. So instead of showing the motor, they have just given the motor terminals here, and we have a two watt meters, 1 voltmeter, and an ammeter. The wirings, procedure for doing the wirings are shown here, and since there are almost 27 steps, they're also given a YouTube link, so you can just click here, and it'll so they beautifully explain how to go about the wiring and the procedure. I've gone ahead and done the setup. Just a moment. Yeah, so I've already done the setup because it would have taken time. So we'll check the connections now. It says the connections are right, and I've connected the motor in star format. So I'll switch on the setup, switching on the MCB, and I'll start the setup. And I'll on the main MCB and give input. So this is an experiment for understanding the no load characteristics of an induction motor, and the outputs. There's not much of a simulation because the only thing you can get out is the readings of the wattmeter and voltmeter and ammeter. And these readings can be used to find the equivalent circuit of a induction motor and find the no load parameters. So to know why you use a no load, why you have to do this test, we can find the efficiency of an induction motor and some other parameters. I think my video is lagging a bit, so I'll stop here, and I think Beryl can take over the session for computer science sections. Thank you. If you have any doubt, you can just post it in the chat box. Beryl, can you take it over?
Yeah, thank you, Akib. Am I audible? Can I just get a feedback quick?
Yeah, Beryl, you're audible.
Okay, I'll just
You can
quickly
share your
try to
screen
share
and
my
then
screen.
I'll deliver feedback. Yeah, okay.
So, is it available now?
Yeah. It's clear and both audible.
Okay, cool. So, good afternoon. So I'll be taking you through a few labs in computer science and engineering domain quickly. Sorry for the early technical glitches that we were going. Unlike the other domains or other streams, simulate. So not much of simulation is required in computer science because already we are working on most of the labs or experiments in computer science domain is being done on a computing device itself, unlike the other domains. So will anyway require a computer, and mostly it won't be requiring internet connection. So it's actually an additional thing for accessing virtual labs. So in virtual labs for computer science domain, what is tried being attempted is to provide a more cognitive understanding or conceptual understanding of a particular course. So just like the other streams, you can select computer science engineering from the virtual labs homepage among the broad areas of virtual labs. And here you will see the vast list of labs. The University of Mumbai syllabus, actually I was able to find that quite a few subjects have already listed among the references a few of the virtual labs from the VLab portal. So I assume many of the faculty members and students might be already familiar with the portal and with the labs in this. So I'll first navigate to the data structures lab. So in Data Structures Lab, which is a lab developed by IIT Hyderabad. It has a new version and it has a older version as well. So if you go to the newer version of Data Structures Lab, you will be getting a window like this. So I have and from that I have selected the merge sort experiment over here. So in merge sort experiment, you can see that just like we have seen for the other streams and other labs, it's a comprehensive learning resource beyond providing a simulation. So here in this particular lab, what is aimed at or what is being tried to do is to give a complete resource for the student who is trying to get a grasp of a particular concept. So a student who is into the subject, into the stream called merge sort for the first time, he will have, like before coming to the subject, he will have very detailed introductory resources, including text and videos. So in all the newer labs, you will find that there are a good amount of video tutorials within the lab itself. So you've already seen Lokmanya, which is a video tutorial beyond the available resource in the VLab portal. So here itself you can find under most chapters, and in pretest there is a recap approaching the experiment. And then there is a explanation of the divide and conquer method, which is standard that is followed in the merge sort algorithm. And then we have the algorithm itself. So this is an algorithmic subject, the data structures. It's something that is beyond any specific platform or a subject platform or language. So irrespective of all languages, like there is a conceptual note along with the how the algorithm works, and also a note of the algorithm, and also the demonstration of the merge sort algorithm is the simulation part of this experiment. So in computer science experiment, you will find that the simulations are mostly demonstrations of how a particular algorithm or a particular code snippet or something that you might have written, or something that is already there for default, how it is working or how it is changing a given set of inputs or a input that is we have already given. That's how computer science experiments in virtual labs mostly work. So here in the demonstration, you can see it's a default array in this case. So if you see other labs, other experiments, you will find that the array used might be custom. You might be able to enter your own array and practice on it. So in this experiment itself, use the next option, you will find how the merge sort algorithm will work on a particular set of numbers. So how the algorithm breaks down the array into smaller units, and how the whole sorting exercise is taking place is observed in every single step by step is the demonstration. So it will make sure that the student who is going through the subject, who is approaching the subject for the first time also, will be able to have a clear understanding by being able to trace the algorithm or trace a code snippet from step 1 to step n. So it will traverse through every loop, every single iteration, every single line of code that the student will be looking at. And once you go through the practice part or the simulation part, you will have an analysis part. So here also you will have a set of resources including text as well as video tutorials, and also there will be comparisons with the other corresponding algorithms. So since this is a sorting exercise, it will have a comparative notes of time and space complexity with other sorting algorithms, and then again there will be self-evaluation part and further references. Self-evaluation will be in some other experiments. You'll find that there will be as evaluation techniques. So I'll close this one And I'll go to another lab, which is the database lab developed by IIT Bombay. It's actually supported by one of the nodal centers. So as a nodal center, this is another thing that institute will be able to do. So you have already seen the VLabs dev portal while Shrestha was explaining. So here in the VLabs dev portal, it's something that will be of interest to computer science domain faculty and students. So how this whole VLab portal is actually maintained on an open source VLabs dev platform, and how maintain all the documentations, frameworks, and standards. Documentation, we have a MOOC tab, which is actually having training videos on how the development process of virtual labs is undertaken. So if you find that there are gap areas corresponding to your Mumbai University syllabus or some subject that you might be interested in, if you find that you have something to contribute to this resource, some experiments or on a particular subject, if you have an idea to develop and deploy on this portal, all the resources that can support you in that process is available on this VLabs dev portal. So lab I was explaining. So which is Gujarat University Department of Computer Science, and in this database lab, DML So in this case, unlike the previous simulator that we saw, which was basically to see an online simulation tool itself. So you'll find both types of labs that will be explaining algorithms using simulations, and also you'll be having experiments that allows you to create your own code and execute it on an online simulator. So this is database lab, DBMS lab is one such kind of an experiment. So here also you will see the normal structure of aim, theory, procedure, and everything. Before going to the simulation window, I'll show you how the simulation works through a video that's available in the procedure part itself. So here, if you go to the simulator here, you will find a set of instructions in the simulator window, which has already specified what you're supposed to do. And in the simulator, you'll find a query window like this. So normally in database management labs, what we'll be doing is we'll be running SQL query on a database tool, which will be MySQL or MongoDB or any kind of database tool. So here we have this particular text box for entering our queries that will be based on the procedure that's explained in the experiment. So here we have the option to enter our queries, and once you enter the query, if you execute a particular query, we will find that. Okay, sorry for that, I went a bit overboard. So you have the execute query option over here, which allows you to execute a particular query after you write it, and you'll get a hint after that. So the table structure which will be created based on the queries that you write on this simulator will be available on the left hand side of the screen. And this is an online simulator, so unlike a normal simulator where you will be working, so you can once you have the table over here, you can perform any other kind of queries over here. Since this is the DDL experiment, you will be able to do DDL queries over here, DDL SQL queries over here. And once you are done with the given session, if you want to save your work that you have done, you won't have the option of committing that particular table like we do in MySQL. So you have an option to save your session to your computer and load it back when needed. Simulator, you can save your work as a text file, and later on, when you want to use your work again, you can upload. The session will be lost, and once you come back, if you want to work on the same session, you can use the file to take back the session that you have completed. So this is how database management systems lab in virtual labs work. I'll just show you the simulation window as well. Yeah, so this is the simulation window. It's a bit different from the video actually. So here we have the instructions and the query simulator. So you have to write the queries according to the instructions and create your tables, and the table structure will be available on this left hand side, and the credentials option to download and upload your import or export your work will be available over here at the right hand side top. So that's about database management systems lab. And syllabus, I think this is contributed by PVG-COET Pune, a college from Maharashtra itself. So in this lab, it's required for the web development or web design lab. I think that's the name of the subject under Mumbai University. So this is one lab that will be useful for that particular subject. So in this PHP, it's again an online simulation. So here in this simulator, actually it's again working on a default code. So unlike, so we can see how the code works during step-by-step execution. So like what we saw for data structures lab, how particular code execution will change or create. In this case, since it's an HTML file with a PHP code, it's how now the set of code or set of instructions is demonstrated over here. So here, as this PHP script gets executed, I'll get a text box with two radio buttons. I'm supposed to select one, and the code is trying to upload an image. When I select one of the inputs and click OK, the page will load again, and it will load. So you'll see exactly which lines will be skipped and which lines will be executed in the window at the bottom. So once the execution completes, since I've given an input already, it will pick that image. So here in this case, it's mouse. So it's supposed to show the image of a mouse, but that image will not be loaded. Actually, this is a lab that is under maintenance. So the image will not be loaded. That the icon of the image will be loaded here since it's lab experiment under maintenance. So it's supposed to show the mouse image once that code gets executed. So if I had clicked for keyboard, the keyboard image would have got executed. So this is a basic simple if-else experiment demo. So I think in University of Mumbai, I was not able to find any labs that were basically on C language. That's why I did not go to the C language specific data structures lab, which is another one that's available, which is actually more interesting. So if any faculty is interested in the subject, I think you can explore that. And also, as I told, Mumbai University has already adopted virtual labs in few of its subjects, as I could find in the computer science syllabus. So all the subjects are available here. We would encourage all the faculty and students to try out the different resources that are available under the virtual labs domain, and also you could try the new lab development window. So there, as I told, that are not yet deployed to the lab main page. And also you'll find the resources using which you will be able to create your own resource. Wind up, return the control back to the organizers. Yeah, thank you.
we have done from our side.
Yes. Is it over now, sir?
Yes, sir.
Thank you. Thank you very much, sir, for your very informative session. And through this session, we came to know that from any place or at any time, anybody can perform the experiment, and there is no limit to how many times it should be performed. Also, we can change different parameters for getting the different results. So it's very nice session. Sir, we have some questions from our participants. Can we go through it?
Yeah, please go ahead.
Yeah. Sir, one of the question our participant asked that, is there any licensed software required for performing the experiments?
No, absolutely no. It is all web-based, and as long as you are having a device which is running an web browser in it, nothing else is required. In few cases, Adobe Flash need to be enabled. Adobe Flash need to be enabled. Other than that, there is no requirement as such. And whenever they have an additional software to be used, they very specifically give the reason, and there will be a provision to download. But in most of the cases, there is absolutely no need to have any other software. And it is device agnostic as well as OS agnostic. That means it can be running on any OS and it can be on any device. It could be a mobile phone or could be a tablet or a desktop or a laptop.
Okay, we can perform any experiment from our mobile also, because most of the students and faculties have mobile always with them, and it is very accessible to them. Thank you very much, sir.
Again, in fact, it is mobile friendly.
Yeah, right, sir, right, sir. Then another one is how we can get access to the lab. That means for performing the experiment. That means if anybody want to access the lab, what is the procedure of that?
If it is a simulation-based lab, it is 24/7 available. And even the RT lab, remote triggered lab, which are without any scheduling, it is also available. Whereas if you are looking for destructive test kind of a test, it need to be scheduled. And ministry is not encouraging it because it is very costly. So hence we would suggest you to use RT labs which are without any scheduling requirement.
Thank you, sir. Again, another some different type of question. If we are performing some experiment which is very long, and if due to some disturbance, if our PC and there may be some problem in our system, can it be performed or backup can be taken of that?
Yeah, once especially we have not put any long duration experiment as of now. But there are experiments which required backup and things of that kind. That is at the back end, we have taken care. But when it is a simulation experiment, absolutely nothing to worry. You can reset at any time and restart. Whereas the experiment which Aishwarya was showing, where once you trigger the torsion test, of course, until it breaks, it will keep on going. And if there is any issue, it will stop by itself and throw an error saying that, okay, due to this reason, it has stopped.
And another one is, if somebody want to ask something, that means if somebody have some problem, is there any help desk available for this virtual lab?
Yeah, in the virtual lab website, they have given supports at vlabs.co.in, and it is an email. You can throw your questions to that. It will get directed to corresponding team. And even in the website, the common email address is supports@vlab.co.in.
Okay, thank you. Thank you very much, sir.
And once you become a nodal center, you can also contact the nodal center, participating institute coordinator.
So different nodal centers are there, and somebody wants to do experiment, he is to be registered in the nodal center.
Yeah. So now we have put our email there, solve@nitk.edu.in. That is there in the chat window. If any institute likes to become a nodal center, they can write to us. Or any institute likes to have such a similar program for their faculty members, they can write to us. And we would like Lokmanya Tilak Institute College of Engineering to be the nodal center and help the neighboring engineering college, because you are already a very long-standing experience in Mumbai.
Yes, yes. Sir, always it's very beneficial for us, and we have given as per your mail. We produce every details which are the requirement of the nodal center to our management, and that's we are in process of that. Thank you very much for this informative session. Now I am request Dr. Chandrababu sir for concluding session. Over to Chandrababu sir. Babu sir, can you unmute this one? Mic and video. Chandrababu sir, hello. Hello.